Hey everyone, welcome back to week 4 for SAT Math. Just to jump straight into it, our first subtopic is nonlinear equations and systems of equations. So our first subtopic here is solve various nonlinear equations in one variable. So we have this equation here, which says root of x minus 3 squared equals the root of x plus 69. So to find this equation, we first have to get rid of the roots, which you can do by just squaring both sides. And then from there, you can simplify the left side, which if you FOIL it out, comes to x squared minus 6x plus 9. And then the right side stays the same. Then you just combine all the terms on the left side, and you can factor it out again into x minus 12 and x plus 5. Now, because we're the solutions for the given system, we want it to equal 0. Well, then positive 12 and negative 5 will be our answers because in the x minus 12, if x equals 12, it will equal 0. And then if x equals negative 5, that will equal 0 as well. Okay, for our second subtopic, we have determined solution conditions for quadratic equations. We have one real solution here, and we have b that is constant. And this equation has exactly one solution. So what are the possible values for b? So in order to find this, we have to set up our equation, and then we have to be able to use the quadratic formula, and specifically the determinant, which is just b squared minus 4ac. So a comes from the 4 in front of x squared, b is given as just b, and c will be the last term there, which will be 225. So we just plug in all the numbers here into the variables, and once you simplify it out, you can equal it to 0. And then once you solve for b, you have to get plus or minus 60 because negative 60 squared is also positive 3,600. That's why it is plus and minus 60. Okay, for our third subunit, we have solve for a variable of interest. So we have this in terms of the radius. So this kind of question is mainly used to trick you, to make you realize you have to figure out how to start this question. And if you look at all the answer choices, they start with r equals something, meaning we have to find and manipulate the variables for this formula in terms of r. So you can do that by trying to just solve for r. So like I said, we're solving for r. So you can divide out the 4/3 and pi, which you'll end up getting r cubed equals 3v over 4 pi. And then you can cube root that to get the final answer. Okay, last subunit for this topic is solve systems of linear and nonlinear equations. Again, we have one real solution, and we have given a as a positive constant. So again, one real solution. What is the value of a? So just like a system, we can just set both equations equal to each other, which in this case is y equals negative 1.5, and that can be equal to x squared plus 4x plus 9, or plus a, sorry. What is the value of a? So then you can just move the 1.5 to the other side by adding it. And it might be confusing, but again, we have to use the determinant. But in this case, we have to use c as a plus 1.5 because we're trying to find a in terms of both systems, which means that c will count as a plus 1.5. So again, like before, you set up this equation, and then you have 0 equals 4 squared minus 4 times 1, which is the constant for a. Then b is the constant for 4. And then c is a plus 1.5. So you solve it out and solve for a. You'll end up simplifying and getting 4a over 10, which is 2.5. Okay, for subunit 2, we have nonlinear functions. We have create and use nonlinear functions as our first subtopic, and we have find the percent change. So this one is actually a fairly difficult problem, especially if you don't really understand what's happening here in terms of the function notation. So you have to pay very close attention to what they're asking. So that we have f of 3 equals 5, f of 6 equals 8.64, and there's for each increase in x by 1, the value of f of x increases by the same percentage. What is the value of f of 5? So if you see here, the whole time from f of 3 to f of 6, aka x equals 3 to x equals 6, we have an increase of the same percentage. Now, because we're looking at an increase in x by 1, we can use this separate function of g to figure out how we can measure it up to f. So we make g of 0 equal to f of 3, and then g of 1 equal to f of 4. So aka every time you increase g, you increase f. And then we can use the exponential growth rate formula, which is g of x equals a times b to the x power. And then you can just plug in the numbers that were given. So x is 3, f of 3 equals 5, aka y equals 5, which is a in this case. And then that will equal to 8.64. So you solve for b, you get b cubed equals 1.728. You will have a calculator on the SAT, so I wouldn't be too worried about how to solve this by hand. And then you'll end up b equals 1.2, but then you also have to plug that 1.2 back into the equation. So we have f of 5 equaling g equals 2, and then you plug in 5 times 1.2, which is the given b that we found, times 2, which is the initial x value of our g function, which ends up being 7.2. Okay, interpret nonlinear functions. So we have this population growth problem where we have p of t equals 50 times 2 to the t, and we want to figure out how many hours it will take for the population to grow 8 times its original size. Now this is another conceptual problem where they're trying to confuse you on how to start, and you have a very wide range of answers. It can be from 400 all the way down to 3. So we have to figure it out. So because they want 8 times its original size, it's easier just to multiply the initial rate they give us of 50 times 8. So then we can just divide out 50 and find what we're looking for. And if we actually solve the problem, t equals 3. And this makes sense because the rate cubed, which is 2, so 2 cubed, equals 8, which will be 8 times the original size. So it's just a conceptual question meant to trick you rather than a truly difficult problem. Okay, next we have connect representations of nonlinear functions. We have an exponential decay graph containing these 2 points. What is the initial value of the exponential decay function? Okay, so when you start this question, we need this formula here, f of x equals a times 1 plus r times x, to the x. That's our exponential rate function. In this case here, we can just plug in our initial value of 1,192. So, and okay, we also plug in 3 and 108 as well. So we plug it in as such, x equals 1 and 3, and then f of x, which is our y, will equal 192 and 108 respectively. So we just solve for a for both functions. So we just divide by 1 plus r to either the first or third power, depending on the initial conditions we use. And then we put them equal to each other because, again, a equals 192 over 1 plus r, and then a also equals 108 over 1 plus r cubed. So we solve this out for r, which, for time's sake, I'm just going to show you the work. But again, you just divide and just search for r. And the reason why we have this plus minus here is, again, you have that square, and a negative number squared is the same as the positive number squared, which is why you'll have that plus minus. Now, when you subtract by 1 here, you'll have that negative 1/4, which will end up being 256 when you divide it, when you divide 192 by 3 over 4. Okay, use function notation for input and output pairs. We have determined the correct function, and we have this exponential function here. We have g of 3 is k is a constant, so we have to figure out the value of k as a coefficient or the base. So essentially, you have to plug in 3 to each function here and just put it in the calculator. Now, again, just for time's sake, I'm going to show you which one's correct. So because we want k as the coefficient or the base, we essentially want k to equal 592, or k equals 592, but we also want g of 3 to equal 592. So this option here, you'll have 3 minus 3 because our initial x is 3, and then you will end up getting 592, which is why this is the correct answer, because we want k, which is the coefficient, 592, to match g of 3 at x equals 3. Okay, for our last one here, we have determined suitable forms for nonlinear functions. So we're looking for the maximum of this given function. So you will just have to solve it out. And again, we have to use this formula here, which can help give us the maximum. So you just solve out the work. And when you simplify and FOIL out the inside, you just multiply everything by the negative 3. Then you plug in negative b over 2a, meaning that negative 3 will be the a, and then that negative 9 will be the b. So once you have it, you can plug in negative b over 2a, which is negative 2 over 3. You plug that back into the original function, and that will give you your maximum value. So if you solve it out, you'll end up getting 75 over 4. Okay, for our solving strategy for nonlinear equations and functions, mainly you guys have to be able to distinguish when to use the quadratic formula. So this question here, we have 4x squared plus 8x minus 21 equals 0. So you can try foiling it out, but eventually that will waste your time. So you have to be able to really quickly figure out how to use or when to use the quadratic formula, just not waste time. So when you have something like this that looks pretty unfactorable, like negative 21, and then you have that 4 in front, which makes it pretty difficult to figure out how to factor very quickly, you can just plug it into the quadratic formula. So quadratic formula is x equals negative b plus or minus square root b squared minus 4ac over 2a. So you can figure out whatever way you wish to be able to remember that. I don't remember if they give it to you on the SAT or not, but either way, you should have it memorized for your AP classes and your more advanced high school math classes as well. But in any case, you do plug in b as 8, and then 4 as a, and then negative 21 as c. You solve it out, simplify, and you'll end up with this plus or minus again. So then you have to account for both the plus and the minus. which will leave you with 3 over 2 and negative 7 over 2. So that is it for the lecture for week 4. If you guys have any questions, feel free to comment on the YouTube video. And if you guys like the video, please like and subscribe.